Hey, are you filming?
Yeah.
All right, cool. It's the January 2023 production update. Today is the 22nd of December. We're just putting together the holiday party, and the dogs are here as well. There's 4 dogs in the building, so it's pretty much chaos. But Secret Santa, I can't say who I got because it's a secret. They're finishing building the media room here. There's Paolo. How's it going? They painted the room, and then eventually we can do like some classes or filming in here, and guests can come in and check stuff out in here. We have all our sample projects and stuff, so it should be pretty cool. Oh, they got a second guinea pig. A few months ago, I think it was like 2 months ago, I think Jen found a guinea pig under the shipping container outside. And so they caught the guinea pig. We brought it inside. Because guinea pigs are social animals, they get depressed if they don't have a friend. So we went out and got another guinea pig from the guinea pig rescue, or the Humane Society, I think. It's because someone couldn't keep their guinea pig. So now we have 2 guinea pigs, and hopefully they'll be friends. They're still putting together the electronics space, but Chris has been working on the SuperLongBoard. We'll probably have more actual updates, but I think the biggest thing is that we just got shipped the new 3rd version of the prototype controllers, and so the plan is to ship them out to the beta testers for testing, and the changes to basically we took the old board and then we had some hardware issues, so we fixed them, and so hopefully the version that we just got will be the version that will eventually go into production. And a lot of the testing right now is just around the firmware. So our beta testers have been continuing to make sure that works and test the features and stuff. And I think I was gonna leave this till some other time so Chris can actually run it, because I don't know how this works, but he made this Christmas thing.
So if you ever want to play it, you can just press this button twice, and then it'll play again.
Feels up. It's holding. Okay.
The other big thing, kind of related, is gSender is coming out with a lot of new updates. I have a full list of features that are coming into gSender, but some of them are going to be related to the SLB. So for example, like being able to flash the firmware directly from gSender rather than having to go to like the STM, like the directly through the chip, for example. But yeah, this is the electronics testing room. It kind of just like is closed, dust-proof space for this type of work. Still getting organized, but it'll be putting together soon. This is my office corner. I've been like working on trying to like make it look like my living room. I've been trying to make it look like my living room. So I made like some frame holders. Actually, one of these broke. But this is Chris on my birthday wearing a shirt he made of me with my face on it, which is that shirt. So I've been collecting these, because every year we make something for our birthday. So like this is my 23rd birthday, and then that's like that picture. It's that shirt on me with him on another shirt with me also on it. Yeah. So, and also you can see we have a lot of dogs because my couch is already covered in fur and paw prints. Anyhow, yeah. So other stuff. So today is the 22nd. So we're like filming this a couple days, like a week before the New Year's. But for people who don't know, we'll be closed basically from the 23rd till January 1st, and then we'll open on January 2nd. There's going to be a couple people, including me, just kind of like doing stuff here and there. A lot of people are just going to be on vacation, so things might ship a little bit slower. Things might take a little more time for responses, but just keep that in mind. And I'm pretty sure a lot of people will also be on holiday, so same song and dance as the last couple of years. Other updates, so we registered a US company, I think earlier this year, for a couple of reasons. One is because we need to file like US taxes, because we just ship so much stuff to the US, and the US government's like, you need to pay taxes. And also it helps facilitate the shipping, because some people might have like had to deal with, there's so many dogs, yeah. Deal with like the EIN numbers and the tax ID numbers and all that sort of stuff. So part of the plan was to like register a US company, and it kind of helps facilitate all that stuff. Also helps sell to like US schools and institutions and yeah, military related things. So, but the bad news is starting on the 18th, we set it up because we need to collect Florida state taxes. So if you're living in Florida, you may have to pay sales tax to us so that we pay it back to Florida. So we don't get any money. We give it all back to the US. So, you know, taxes, fact of life, I guess. But that's all set up. And then as we hit different thresholds in the US states, New York, California, whatever, we're more popular, we may slowly start to hit those places, and then you may see sales taxes charged on that order. We're continuing to understand how the U.S. tax system works, so you know, we'll figure out things and try to save money where we can, but obviously, like, we can't skirt the law. Yeah, LongMill production, we're continuing to move smoothly on that. The packing, we've been a little bit busier with the packing team, so Patrick said, you know, some things might take a couple extra days. Some people are just taking vacation around this time, and yeah, but we are bringing on another packing person, so that'll kind of like even things out, and then we're expecting some students to start working here in the new year. And although they're not going to be working in packing, they'll like help with the production operation stuff and the QA processes. So that will probably speed up our production rate a bit as well. And obviously we have the AltMill and the laser like in development, and the AltMill parts will get in soon, so we'll be establishing some production for that. So more news to come for those things. As I was talking about gSender, there's going to be a new version coming out, like a new main version to replace, I think it was version 1.2.2. So right now you can try all the features that will go into that build right now with gSender Edge, which is in version 1.3.10, I believe. But essentially what that's coming with, and this is not like an exhaustive list. Is it an exhaustive list? I don't know what English is hard. This is just some of them. I didn't write I don't think I wrote all of them, but you could like, there's a lot of stuff. But essentially one is improvements, bug fixes to running the Vortex, and that will come into the main build soon. Probing with the touch plate on all four corners. So a feature that a lot of people have been asking for is if you want to set the origin to like the top right corner or any corner that you have, now you can change that as well. Communication flashing and firmware communication for the SuperLongBoard as well as other features. Faster and smoother G-code visualization, which is actually something I noticed right away because I'm running it on the gSender Edge on AltMill, and I do testing for really, really big files. So like, I think this file had 1.5 million lines or 15 million lines, and essentially like the computer has to visualize all of them. So it'll cause the software to stutter if it's like super, super big, but with the new update, it's like it's buttery smooth. It was like, yeah, it was amazing. We also have a zeroing warning, so the button for like go to zero and zero the DRO is like very close to each other. So you can set a warning that's like, are you sure you want a zero? Because if you mix them up. But there will be potential UI changes that will also like adjust the distance between them to prevent people from clicking the wrong button. We made improvements to the gamepad and the controller functionality, so that there's been more testing, more adjustment to the smoothness of the jogging, as well as like the system to like implement custom controls and things like that. that's also there. And that's like a build on top of what we already have currently. Improvements to the remote mode and the pendant functionality. So now you have a QR code you can scan, so it makes it easier to set up your phone to control your machine, as well as maintenance warning and tracking system. So you know, there's certain maintenance aspects, lubricate your leads, linear guides, and change your V-wheels, things like that. There's a part of the software where it can track how much time you spent with running the machine and give you a suggestion on when you can make adjustments and do the maintenance. And you can add custom maintenance requirements. So if, let's say, like you have a vacuum and you're like, oh, I want to change the filter every 200 hours, you can put that in there as well. So you can add custom maintenance checks. It's kind of like in a car where you have a check engine light, or like change your oil like light. It's almost like the same, where it's like it'll just remind you that you need to do these things. So yeah, I mean, basically the idea is to make gSender work more reliably, as well as add some of the features that will go into the SLB, and just make it easier for people to use the features that aren't really used that much. I think partially because they take some setup, but if we can streamline it and like kind of like make it just work out of the box, I think that'll be really beneficial for everybody. All right, we're gonna go to the AltMill because Johan set up the Sienci router there, and we also have the AltMill we can talk about too. Oh yeah, so you can see we're slowly tidying up the back of the office. Oh, hey, Adam. Oh, and they just got this like mill machine that's also CNC, so we can like prototype more parts, metal parts. I think probably when we make the plates for the AltMill, we'll be able to use that. I think for comparison, I don't know if the old mill is still here, but for comparison, that's like a chunky boy. Oh yeah, there's the old mill. That's the old mill. I don't know if you can see it. All the way back there. So that's the replacement for that. And we also got the new CO2 Laser Cutter. So now we have two. So yeah, we got a government grant to like cover some of the costs for improving production for manufacturing in, it would be Southeast Ontario, yeah. So there's that. So we're using that for production, and that one will also be for backup basically and prototyping. So thank you, government, I guess. Yeah, we're here with the AltMill. This is Johan, as you've seen like 5 billion times. Sometimes, huh?
4 billion.
Yeah, sometimes known as like the more handsome and more articulate version of me.
Goodness. Handy.
Yeah. Yeah, the YouTube comments are a little saucy.
Mm-hmm.
But yeah, we've been working, well, mostly Johan's been working on building the CNC router. And as you guys may or may not know, the plan is to make something that's like a spindle, like has the benefits of the spindle, which is like quieter, more powerful, speed control.
Build a better Makita, but
yeah,
you know, has more stuff
yeah.
from the spindle.
Yeah, yeah, and then like fix the flaws of the Makita, which is like it's loud, it's very hot, and doesn't use ER collets, blah 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 blah. Oh, and the button breaking, like some manufacturing issues, like the bearings being kind of wonky and sometimes failing and all that sort of stuff. So basically, initially we were like, oh, we're going to use the universal motor, which is like the AC motor that they use on the Makita. So basically just take a Makita and then build like hardware around it to make it better. But then we kind of started dabbling with brushless DC motors, and then eventually we're like, how would you say it?
For the buck?
Yeah, like like being so much better, it's like, why not just go the extra mile? But after like months of looking for motors, Johan finally found an option, probably not the one that we're gonna go with in the long run, but it's pretty representative of like what we'd want to use down the line. So yeah, I can kind of like go through a rundown. So basically, this is a 400 watt brushless DC motor. I believe they use it for like hand mixers and like high-end blenders, like for commercial use. So a couple advantages of brushless DC versus the AC motor is one, there's no brushes. So with the Makita, you have to replace the brushes once in a while. With the brushless DC, because there's no brushes, there's nothing to replace. And also it factors into the noise because there's always rubbing on the, what's it called, a commutator? Yeah, the commutator. There's always rubbing on the commutator, so that adds noise and friction and heat and all that sort of stuff. The second thing is that the efficiency of the brushless DC is like much, much higher in like the 80 to 90% range. Whereas with the universal motor, that's like 40 to 60%, right? So like for context, like the Makita like running operationally probably draws like 500-ish watts, but if you're like 50, like that's the output power of the Makita, it's like cutting, but if you're running 50% efficient, hypothetically, you have like half of that 500 watts of heat essentially. So there needs to be like a big fan, and then the big fan causes also heat and yada, yada, yada. With the brushless, obviously, because you're running at 80 to 90% efficiency, you're only needing to cool like 40 to 60 watts of power, which is like pretty easy. Like that's, for context, like less than a CPU would need to handle. So like so even you could even have like a smaller fan and heat sinking to actually cool the motor. Also the other thing is like the RPM range is much broader, especially on the low end, because you can run it a lot slower than a universal motor. And because the control for the torque is a lot advanced, there's a lot of parameters we can change to be able to get the motors to perform the way that we want and make them more optimal for the application. So yeah, so basically Johan's like taken the motor and then he Frankenstein and coupled it to an original Makita body. So there's like a armature inside here, and just the shaft, we like coupled them together. But it works. Like he can actually cut stuff with it. And so basically the testing that we've been doing, well, the main question is the motor powerful enough, and will it work for this specific thing? So one sort of thing that, like one part of the next step is that the motor that we got is an off-the-shelf motor, and it's limited to about 8,100. I think the max is 8,100 RPM, which is a lot lower than what we want to be hitting. I think around 15,000 RPM is like kind of the average speed. But the Makita goes up to 10,000 to 30,000. So that's generally the broad scope of what speed we want. Although I don't think it's generally practical to run it faster than like 25,000 RPM. So, and most spindles, they don't go up past 24,000 RPM. So there's like really niche situations where a faster speed might make sense, especially for engraving and things like that. But unless the motor's super balanced and the machine is super balanced, the vibrational, like just the vibration from the motor itself is probably going to cost more like mispositioning than like the advantage of spinning faster, essentially. So what we've been basically just testing is like testing till failure. So you just run the machine into like a chunk of wood until it like stops, because what it tells us is like how much power it will draw like all the way up into failure, as well as how the motor handles that. And what we were looking for is the motor to keep its speed constant all the way until it stops. So it's like same speed, done. And for them, like that's what we've been seeing on this. And that's good, because with CNC machines, the idea is to always keep the same like strip load on the machine. So some motors, so for spindles, VFD 3-phase spindles, their kind of strategy is like have enough power to like not drop in RPM, but there's no closed loop feedback so that it knows it's slower than it's supposed to. It can use the phases of the rotating field to like know where the position is and how much there is in slip, but in terms of compensating for that, there isn't that mechanic for it. So like from my experience using spindles, if you like push them past what they're supposed to be rated for, they'll just like bog down, and that's not ideal for the cutting. And it kind of is like a cyclical thing where it's like the force against the bit is correlated to like how much chip load there is. So the faster you're spinning, the less force you're taking per each cut. It's kind of like you know, shoveling snow. It's like you take a little bit of snow and you shovel, like you toss it. It's not so heavy, but if you take one big scoop, you're like, oh, it's a bicep workout. You know what I'm saying? So kind of the same thing with this. Like you take a bunch of small cuts, or you take a smaller amount of big cuts, but the big cuts take more force. And so as you cut, if the motor slows down, then each cut becomes bigger. And then because each cut is bigger, it's more force, and then the motor has to struggle even more, and then eventually it bogs down and bad things happen. If the motor can run at a constant torque and a constant speed, a constant speed and adjusts its torque as it's cutting, then it reduces that chance. And so you can have a more consistent cut, and that's essentially what we want to do. So even like the size comparison for like an 80 millimeter spindle that runs at 1.5 kilowatts, it's just like big, just chunky, but the power density of it isn't like so good as a brushless DC motor. So in a way, like that's like the general details. So
We'll explain more.
yeah,
This continues. We'll share
yeah, we can do a TED.
processes and stuff like that.
We'll do like a TED Talk. Yeah, look out for Johan's TED Talk. But yeah, so like the 400 watt motor, it's like almost equivalent to the Makita's performance, and it's using like 1/3 to 1/4 of the power. So there is kind of like question mark of like the marketing side, which is like Makita, 1.5, like 1,500 watts of power, 1.5 horsepower, yeah, blah, 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 blah. But then it's like you actually cut and it's like 400 watts of actual output power. But then we're like, oh, 400 watt motor cuts 400 watts worth of cutting. Why more small number? It's like a horsepower race. So that's going to be like a interesting thing because it's just more efficient. It just needs less power, but it's like the rating of the power is based on how much power you're drawing from the wall. So it looks like there's less, it looks like a less powerful thing. And it's tiny, it's so small. So the plan is to get the bigger motor, which in theory at 24,000 RPM will run at almost a 1.5 kilowatts, right? Like just like slam into the wall, like all.
I don't have it yet, so I
Yeah.
can't guarantee, but here's hoping.
Yeah, like it was 0.55 Newton meters, right?
It's gonna be more than that now, I think, after the latest discussion with Stava.
Okay. So in theory, the motor for the new one will be bigger and like have the power output like comparable, but like because of efficiency, be more powerful on the machine itself. So more power, more good, and less marketing confusion. That's kind of the sitch. In other news, we're working on the mechanical. Like you have some concepts for like loosening tool changes, either toolless or like single tool, like make that easier. Although like, you know, another part of it is like the 2-wrench thing is like super reliable, or even like the button and wrench thing is also like super easy. So there's not like a ton of room for improvement. I think we want something that's like bulletproof rather than like super easy and janky kind of thing. I think the new samples will probably be here second week of next year.
So we've got a 800 watt sample in today.
Oh, okay.
Have it.
Yeah.
We will run it during Christmas.
Yeah.
Well, after Christmas.
Yeah.
And
I don't know if the mic picks it up.
So basically, like, we have different motor suppliers giving us different motors to test, and we like these samples are ones that we also request them to make for us. So they're like specifically tuned, maybe slightly less off the shelf. So one of them is going to be 800 watts, and the other one, right now I'm not sure the wattage yet, but I think they say they can go up to 1.1 kilowatts, which is great. With the efficiency. So so the 800 watt motor is going to be here like today, supposedly, and we're going to test it after Christmas. And the even more powerful one maybe sometime in January or February. So after that, I think the motor selection part of it will hopefully be done, or at least maybe with one more round of motor sourcing. Then we can zero in on the motor, the power envelope that we actually want. And after that, it would just be mechanical design as well as like packaging of the motor. So like, hey, you know, I need mounting holes for, you know, putting this into our tool. Like, how do we do that? How do we attach the shaft of the motor to the shaft of the part with the collet? So there are things like that needs to happen, but hopefully we will get motors we'll get the motors we want by Feb, and then maybe one more round if we're not lucky. And then I guess like at that point, we'll show you more.
So yeah, I think like building on top of what Johan said, the motor selection is kind of, there's a multiple layers to it. One is like the price point. Obviously, the bigger the motor is, the more expensive it is. And there's also like the more powerful the motor, the size is different too. So like it changes how we put them into the body of the whole router spindle thing. But yeah, so kind of like the plan is we want to make sure it works better than the Makita power-wise. Like anything the Makita can do, we can do better sort of deal. And then there's also like, do we want to make it work with just the LongMill? Because that was like the original plan. Like we want to make something that LongMill users will replace. But if other machine people want to use it, either like more industrial machines, bigger machines, ones that can run faster, so on and so forth, if the router can handle all that sort of stuff as well. So if that's sort of the long-term plan, then getting a bigger motor and kind of like making it work for everything sort of makes sense. Or if the price point is like, let's say $10 difference between one motor than the other, then it might just make sense to go that direction because the cost difference is so small. So we're not quite sure yet. We're still working on it, obviously. So as things happen, we'll talk about that more. So yeah. Other news, we have the AltMill that I've been using for the last couple of weeks. I've just been doing personal projects mostly to not really like test the performance of the machine, but to get an idea on what you would use it for. Like what benefits do I get from having a bigger machine versus a LongMill? And I've been really enjoying it. The AltMill definitely changes the workflow and the process of what I do with our CNC machine. So I can like talk a little bit about that. So I think the first and the biggest difference is just this, because it's a 4-foot by 4-foot machine, I just buy sheets of plywood and then I just shove it into the back. Like I just slide it in. I have the back of it hanging out and then I just screw it into the wood. And then I just like cookie cutter all of the projects on the one sheet of plywood. And then once I've like done with that, I just pull it forward and then I screw it back down again. I do the other sheet. So it's like really convenient because you don't have to cut materials down. Obviously this shop is like pretty big, so I have a lot of space to go back and forth. But yeah, just the convenience, because usually if I want to buy like a sheet of material, I go to Home Depot and just ask them to cut it into slats, or hey guys, or use a table saw. But you know, if I don't have to do that. The other thing, so I've been like using the touchscreen, which is really, really handy. I don't know if I can demo it. I don't know if it's plugged in. Yeah, it's plugged into Johan's laptop. But one of the other things that is like will potentially be a like a hassle is with the LongMill, because it's a lot smaller, you can just put your computer next to it, and then it's not so much work to like click the buttons and make it move and all that sort of stuff. But the AltMill is a lot bigger, and so like I have my computer over here, so I gotta like work on it and come back and then like make sure I'm lined up. And obviously it depends on the distance between the computers, but just having a screen like literally right here, and I have it on this stand thing from Amazon, and I can just like do it, and I can like work on things right next to the machine, has been like so convenient. So I would like to, you know, this is one way of doing it. I have a computer down there, and then I have the touchscreen, and the touchscreen is super cheap. I think it's like $100 on Amazon. So, and it connects with HDMI or USB-C. And the touchscreen interface with gSender isn't perfect, but it's like 95%. Like the only issue is sort of like, there's no zoom function on the visualizer because you need a scroll wheel. But otherwise, like, you know, I can like do things, and I can like input numbers. I have a touchscreen keyboard that pops up. It's fantastic. And yeah, so I really like that. So I want it to be part of the process of the AltMill. Not really like specifically AltMill related, but just like as we have the LongMill, and this works for the LongMill as well, and you know, so on and so forth. Other things, so the machine is like stout. It's where the machine stops being the limitation, and your bits become the bits, and the material become the limitation. So with hobbyist machines, the deflection that you get, a lot of it comes from the machine itself. And that's pretty common with all machines. But once you get into this sort of realm, a lot of deflection comes from the bit itself. So you're like a bit limited by how big your bit is, essentially. And so when I set the feeds and speeds, I just go straight from the Vectrix like default. I don't even like bother setting a speed to it, because I just know that the machine's going to be able to handle it. And although it would be much better practice, and I wouldn't recommend doing it that way, and this is like partially for the sake of testing, I just go with the defaults, and they run fine. And I have obviously the speed control, like the speed adjustment on gSender, so I just like keep bumping it up until I get to the speed that I want. Yeah, so it's been pretty much bulletproof in terms of the rigidity, and so it's nice to like not have to dial things back to get what you want. And I can spend more time to optimize the feeds and speeds, but a lot of the projects that I'm doing are just one-offs. So they might be like a 10-minute cut, a 20-minute cut, and like saving 5 minutes, it's like doesn't really matter if I'm saving 5 minutes here or 5 minutes on the computer. I can just set it up, let it go, and walk away, come back later, and I'll have a project that's done. So that's been pretty awesome as well. And yeah, so I think like really excited for being able to use the machine and like not have it janky. Definitely opens up a lot of potential projects and makes it a lot easier. Even though you can do a lot of the projects on the LongMill, especially the 48x30, just like a little bit extra room does make a difference, and it is like a bit more convenient. And now I'm like, okay, I really like not having to take a like not having to cut down the material, but I still have to slide it through. But if the machine was like that much bigger, then I can just put it on one time, and there's no cutting and no hassle. But I know that will get some people very, very excited, and I will not make any promises. But the more I use this, the more appeal I can see, like why people want something bigger and why people want something more powerful. And I think that this will be definitely a very popular option. And obviously, once we build the new version, so in terms of the production, we had a batch of linear guides, lead screws, ball screws, and all that sort of stuff. That got delayed in shipping, so it won't be here until middle of January next year. Extrusion samples are on their way, I think, now, and I think they'll be in next week. So we'll be able to start building out the machine, the first version of the prototype. That's kind of where we're at. We were hoping to get one working by the end of this year, but it's probably looking like end of January, I would say. And then as the parts get shipped and come in, like we'll get everything probably by mid-February, my best guess. So yeah, that's for the AltMill. I posted more information about every project, everything, as well as answering some of the questions that people posted on the YouTube channel and the survey. And yeah, AltMill project continues to chug along, and I'm excited for all of that to happen. I think I need to open the, let's go open the UPS door. Hi, how's it going?
Standard food service, yeah.
They're filming.
Oh,
is that okay?
And your name?
Andy. Looks like we got some anti-fatigue mats or whatever. Yeah, okay, more updates. So, so I think we were talking about this in the last production update, but for SLB, one of the things we wanted to do was to have an onboard computer, and we kind of put that on the side because the amount of work to put a computer on the board was like more than double the work than just having a computer separate and then having the board separate and then just having a way to connect them, because it's like behind the curtain, it does exactly the same thing. So I've been working on figuring out some different computer options, and one that I've been using is the B-Link computer from Amazon. And I plugged it in with the touchscreen, and it works like fantastic. It's got Windows, so I can like use it for networking. So I have it connected. So I have it wirelessly connected to my computer over there. So as soon as I make a G-code file, I save it on the network, so it's like on this computer immediately. So I can go save something here, walk over here. It'll be on this computer as soon as I get to this point here. Obviously, it's not immediate because it's like a connected network, so the files have to be transferred. But like, because those files aren't very, very big, they're like a couple hundred kilobytes, maybe a few megabytes at most. And it's on the local network, it just like feels instantaneous. Also, I have like remote access on my computer in my office, so I can also access what's happening on here like through an app as well. So just like a lot of different things. But basically for the B-Link computer, we can buy the computers at wholesale for about $90 US, and they can like we can create a master image that has all the software from the computer, like gSender, the app to like network, like the stuff to network the computer. We can have like the tutorial, like the what do you call it? The trial software for like all the software that you would use for making G-code. Like we can like preload a bunch of stuff so that people can just buy it, and it'll have like set up with like a bunch of software they can like get started and use. Obviously, the computer is not very expensive, so you don't have to worry about getting. It isn't like dust. Like there is a fan on it, so we do have to like put some filters around it. But comparatively, it's like pretty inexpensive as a computer, especially given how powerful it is. And then you can connect a monitor, which is about $100 for the touchscreen thing. So the idea is we make a batch, we buy a wholesale batch of those with a master image with like all the CNC related stuff so that people can buy it. They can set it up the way that I've set it up, and they don't need to worry about having another computer. Or they can have another computer, but it would just be for like making the programs and designing things, and it can be a nice computer so that the not nice computer, you can treat it the way you want to treat it, you know? So they can make the computers, no problem. Now it's just a question of how many people want it. I'll keep working with Chris to kind of decide what would be on the computer, and obviously we'll have the customers provide their feedback on what they want to see in a computer system like this. And what I'm hoping for is before we have the SLB start shipping, this will be an option so that people can actually get like the full thing that we all dreamed of in the long run, which is an integrated system that with the computer and the SLB that all works on the machine. You don't need to get anything else and still be inexpensive, and also have the headroom. So like, because it has USB ports, you can connect the webcam. So we maybe find a way to like integrate those things, and we have Ethernet as well, so it can be networked and connected to SLB through Ethernet as well. So yeah, that's basically that. So I will probably put out a survey or like tell people more about the computer thing down the line, and yeah, we'll go from there. So okay, we'll go back to my corner in the front. Oh, so the other thing is Ikenna's been working on the laser stuff, so you guys might have seen the video. He'll probably be more in charge of updates on that. So we'll like talk about, me and Ikenna will figure out like what's the best way to do the communication, but Molly's always on top of it. So I'm pretty sure as long as you subscribe to the mailing list for that, and check out the video and like stay in tune with those things, you'll be able to get the updates there. 1/4-inch roughing bits are on the store. I don't think we've like promoted or put out any information about that yet, but that's available. We also have 1/4-inch Makita Collet, precision collets that we've made on the store page as well. Also not promoted, but they are available. Some people have been asking about the QA process for our production. It's kind of like too early for us to like talked a lot about the QA process. I can only really share what we learned from the LongMill and how that goes into the AltMill essentially. So I guess just as a brief answer, and there's more information on the blog post, but there's a couple of things that we've done with the LongMill that we've done to like improve the customer experience and the quality of the machines. The first is that when we first started, we got a lot of parts off the shelf, primarily because we're building so few machines. We didn't have like the capacity to actually make the parts ourselves. But the downside of that is that the quality of the parts is variable depending on the supplier, depending on like whatever you get. So that was kind of like the root of a lot of problems. Like some parts don't fit together, and we would have to like double check that they would work before we send them out to the customer. But as we've like grown and we are building more machines, we slowly moved to manufacturing everything custom and like controlling the manufacturing process of it. Even if it's like a part that's like off the shelf already, we'll like make our own version of it. Even though like there's maybe no difference between off the shelf and our parts are just made to a higher tolerance, and they're spec'd at the factory to be made at a higher tolerance, even if they don't need to be, because it goes into like another thing that we've learned, which is that it's always cheaper to not have to do customer service essentially. Like if a part is bad, a part doesn't fit properly, so on and so forth, the amount of time, the amount of effort we need to, and also like the how do I say, like the frustration that the customer faces just by like getting something that doesn't fit together properly, it could cost like a lot of money. So rather than spending the money on fixing the problem, we just keep the problem from happening here. And that a lot of the discussions that we have is like, oh, we have this batch of parts. What do we need to do so that that isn't the problem? And the other good thing about that is that it narrows down what the problems could be, because we also like keep historical information about like how the QA of the parts are. And so if we're like, oh, power supply is like almost never a problem, and we need to do like help a customer fix a problem, and they're like, hey, my machine doesn't turn on. Obviously, the power supply is in that chain, but we know statistically, because in our QA process that's not been a big problem, then we know the likelihood of that being the problem is lower. Obviously, it doesn't eliminate it, but we can like use that as a factor in the analysis of the problem. It also like feels better to make better stuff. Like, you know what I'm saying? Oh, the other thing is like it's very important to like make parts better from the beginning. And what I mean by that, and the design better from the beginning. So what I mean by that is like, if you require really, really high precision components, to meet the specs of the machine that you want, you're always going to be chasing the precision based on the precision of the parts. But there's ways to design the machine to work better because you just design it better. So like, for example, when Chris designed the extrusions for the LongMill, they were like made symmetric. To design the design of the extrusion, because they're limited in their experience to know what the straightness is going to be. But there's like different factors like how thick are the walls, where like what the symmetry of the walls are going to be, and so on and so forth, to make sure when they get extruded they come out straight. You know, the AltMill comes with different parts like machine faces, like self-aligning kind of like structure, so on and so forth like that, so, which means that the machine can use lower tolerance parts but still be accurate. And it doesn't mean like it just means that we can make the machines less expensive but still have the same performance as a higher end machine that requires the higher end parts, essentially. When we built the first version, we had a lot of problems, quality issues, as well as like learning, like we're building like 30 machines a month at some point. So it's like, you don't find out about the problems, and the problems are really isolated. So you don't see the trends. But now, like when you're building 100 plus, 200 plus machines per month, you see, like, you have one problem, you get a lot of examples of it. So we're able, obviously, more machine, more problem, but also more machine, no problem, much faster. So, yeah, like, I'm pretty sure a lot, like, what we learned from the first version and then going into the second version, we were, like, so worried that we're gonna run into a lot of problems building Mark II, but then, like, that just never came. It just fit together really well. Very, very few customer service issues, like much less than before. So it feels like even though we're selling like several times more machines than we were before, the actual number, like the actual amount of work that we're doing to help the customers, it's been basically the same, just because we just have fewer problems in the grand scheme of things. And even with the LongMill now, like a lot of the parts have changed over in the past 6 months to eliminate just like the most edge cases. Like for example, the Acme locking nuts, like we send out extra ones. At first we send out extra ones because some people would like strip them. And then we redesigned it so that we use M5 bolts, and then they're like basically impossible to strip. Because like the M3 on the Acme locking nut itself was already like, you would have to be a gorilla to like strip it. But like we have customers who are gorillas. Like when you have thousands of customers, some of them are just gonna be like super strong. So then the new version, which is like so overkill, is like impossible. Like you would have to be like a Tyrannosaurus Rex, you'd have to be like Godzilla to like strip it. And I'm sure like we will run into those things, but that is like, that was the solve. Like now we just never have to worry about it. Like, yeah, so we just solved the problems with design essentially. The AltMill, the benefit of this is that a lot of the parts are machined and they're spec'd to be high tolerance, even regardless of whether they need to be or not. So in theory, like the variability of the quality is lower in a way. And I think also we're doing some of the assembly here because like there's alignment and testing that we need to do before they get shipped. Some of those problems will be like caught before they get shipped out. So we'll be able to learn exactly what the QA problems may be going into it. And that's sort of like the way that we'll be able to do it. So yeah, that's pretty much kind of like the general rundown. You know, I have some pictures and some communication that we've had to determine the tolerance against things like that. So yeah. Anyways, it's a little bit chaos here. That's pretty much all the updates. Thanks for watching. Make sure to read the blog. There's going to be always lots of information there, maybe some things I haven't covered on the video. And happy holidays. We'll be back on January 2nd, and we'll catch you on the next production update.